In this chapter, we're going to be looking at organic molecules, and as you probably know from previous junior science classes, there's one place that we know that we get most of our hydrocarbons from. So in this question here, I'm asking you, what is the link between these pictures? And the answer is that it all comes from a natural resource called crude oil. And crude oil is literally the oil they get out of the ground. They can drill for it under the sea, or they can drill for it on the land. And it's the oil that they get from that before it's processed, okay? And they get it in the barrel. So before they actually process it, it just literally comes out as this thick black liquid, which is a mixture of hydrocarbons. Okay, and we're talking lots of different hydrocarbons in all shapes and sizes. And in order to separate this mixture, so this is going back to year 7 science now, we need to tap into the fact that they have different boiling points. And if a substance has a different boiling point from another one, that means that it will boil at a different temperature. So we can use this fact to separate them. And we separate them using distillation. Now, you've probably heard of distillation in terms of purifying a substance, but this particular type of distillation is particularly useful in separating multiple substances. Now, they call this type of distillation fractional distillation. And in a way, it's kind of cheating, because normally in a distillation, the person doing the distillation would have to apply heat to a mixture, and they would change the temperature over time. And as the temperature goes up, they would carefully slow it down, and they would collect different vapors that boil off at different temperatures into a collection vessel over here. And it's quite a skill to do normally in the lab, and every substance, every chemical has its own specific BP, boiling point, okay? And it's unique to that substance. With fractional distillation, what we do is we put all of the mixture in to the reaction, the distillation column here. So this is called a distillation column. And the crude oil is heated up at the bottom. So the heat is applied here. And so it's hottest at the bottom. And what happens is gradually the mixture will slowly start to boil, and it travels up through these little valves here. These are actually called bubble chambers. Bubble valves, sorry. Bubble cap valves. Bubble cap valves. And they travel up and into the next one, only if their boiling point is matching with the temperature in that particular section. So if their boiling point is higher than that, it can't make it up the column, so it just stays in here. So components with a higher BP stay at bottom, and here the gases rise. Gases with lower BP rise up, and gradually they travel further and further up, and you get less and less gases making it up here now, because the boiling points would be lower of those gases. And gradually, as you get less and less making it to the top, the substances with the lowest BP make it all the way up here. And that's substances like your butane and your propane. So just below that, you've got your petrols, which we use for cars, kerosene, which we use for aircraft fuel. This here is gas for cooking heaters. Then we've got our diesel, cars as well, cars and machinery. And down the bottom here, we get the really thick substances that tend to have very high boiling point. And these are the oils, the waxes, and the asphalt, so the stuff we use for roads. And that actually has such a high boiling point, it just runs down. So it's a runoff effect. It goes down into, gets tapped down there. So that's what happens in sort of as a brief overview for fractional distillation. And the reason they call it fractional distillation is because of these components here. And they call these fractions because they are parts of the mixture. So that's how we distill crude oil. Now, the main components of crude oil, the main hydrocarbon that we're interested in, is alkanes, particularly for fuels. And I know that in year 10 science you would have learned potentially about some of the alkanes and their names. So I've got a table here for you to complete. So I want you to pause the video. Like by me, methane's got 1 carbon. I was thinking 4 hydrogens. We've got ethane with 2 carbons. We've got propane 3. And you can see that each time you just increase the number of carbons and the prefix will change on the alkane there. And the number of hydrogens is always equal to 2 times the number of carbons plus 2. So the general formula for it, which we'll do in a minute, is Cn and Hn 2n plus 2. So you can see here that every time we simply add a carbon on, fill it with hydrogens. So the general formula is Cn H 2n plus 2. And that's for all alkanes. So these are what we call saturated hydrocarbons. And the reason that they're saturated is because they have no double bonds. They are full, effectively, of hydrogens. So there's no more hydrogens we could possibly fit onto each of these carbons. Now, naming these is really important. So we use a naming convention which is called IUPAC naming, and it stands for the International Union of Pure and Applied Chemistry, which is like an international group, which helps to make sure that chemistry is accessible for all different nations so that everyone can sort of communicate properly. So I've got an example here for you of the way that we name them if there are branched alkanes off them. So for example here we've got the main alkane, which is 5 carbons long, and so it's based on a pentane alkane. But then we also have what we call a methyl group, and that's on the 3rd carbon. So that's where the 3 part comes from. Okay, let's use a different colour there. Part there. Okay, for this one we've got the longest chain, which is 5. So that's there, pentane. Then we've got 2 methyl groups. So on the 1, they're on the same one. So that's where the dimethyl comes from, because di is the prefix for 2. And then we have the 2 carbon numbers that they're on. So you could have different carbons, but these are on the same one. So they're on carbon number 3. So we have 3 twice. The last example here, the longest chain we have is 4 carbons. Now, you could actually have a different chain here. That's also 4 carbons. And also you could look at it like this, and that's also 4 carbons. But no matter which way you draw the longest chain, they're all 4 carbons, and the other groups actually end up being on the same carbons. So with this orientation, they're on the 2nd and 3rd carbon. If we do the main one through the way it's drawn, they're on the 2nd and 3rd carbon again. If we draw it the way like this, again they're on the 2nd and 3rd carbon. We look at where the groups are. So it doesn't matter which way you draw the chain. The longest chain is 4. We're going to draw it the easy way to look at there. Okay, and we've got 2 methyl groups, so it's a dimethyl, and it's a butane because there's 4 carbons, and they're on the number 2 and number 3 position, so that's where you get the 2,3. So it's 2,3-dimethyl-butane. So the rules are, first of all, you find the longest carbon chain, okay? So this is the root of the name, so pentane, pentane, butane. Then we look at numbering the carbons, all right? So every single one we're going to go through and we're going to number the carbons. And we start so that the substituent group, the one in green here, is on the lowest number we can. So we're going to start on the, it doesn't really matter with this one. Let's start on the left and go to the right, but we don't necessarily have to go left to right. With these ones, they're in the middle, so we're going to go, it doesn't matter again, left to right. So that's carbon 3, 4, and 5. And with these two, it actually doesn't matter if we start left or right either. So 1, 2, 3, 4. It would matter if we're going left to right if it's if it means that we can have lower numbers here. So these you want to be as low as the lowest option. So if you have to renumber them the other way, that's what you do. So once we've numbered them, then step 3 we'll get to in another lesson is about adding a suffix. So that might be like an alcohol group would now have ol at the end. An alkene would have ene at the end. So we'll talk about that later. And then you've got your substituent group prefix, which we've just talked about. So you've got methyls, we just looked at. But you've also got your ethyl groups, which is where you've got 2 carbons. Propyl, butyl, pentyl, and hexyl groups. So they're possible groups that you might get added on. So these ones in particular were just methyls. But you could get ethyls or propyls quite commonly. So let's have a look at this example. I want you to pause the video and have a go at this one. Okay, so the first thing we do is we're going to find the longest chain. So if we draw it this way, we get 6. If we draw it this way, we also get 6. So it doesn't matter which one we go for. Let's just do it that way to be easier. Then we're going to number them. Now if I number this way, 1, 2, 3, 4, 5, 6, that will end up being a 5 methyl, which is too high because I can easily number the other way. And that way it will be a 2 methyl. So that's what we're going to do. We're going to number it this way. Okay. Then I'm going to circle the substituent group, which is a methyl group. This is hexane. Okay. And the carbon number is 2. So now I'm going to put it all together. It's 2 methyl. Okay. Next example. Okay. So once again, find the longest group. Okay, so that's a hexane. Then we've got our substituent group, that's a methyl. And if we number them going this way, 1, 2, 3, 4, 5, 6. So it's on the 3rd methyl. So it's going to be 3 methyl hexane. Okay, last example. Oh, sorry, that's it. That's the only other example. So that's how you number them. And how you use RU pack naming.